Hello everyone. On this video, I'm going to talk about the t-test and the z-score commands. And these are two important commands that we will study this week. So the dataset that I'm using is the college distance dataset. So again, when you start your do file, you clear anything that you might have in terms of the dataset. Like here, if you have already a dataset that you need, then you need to clear it. If you have any open log file, then you will execute this command. For me, I don't have any log file open, so I will make this command green so it doesn't run. And then set more of so that you don't see a long list of output. And then I'm setting my directory where I'm putting all my data files and data types, whether DTA, CSV, or Excel. So I'm putting them under a folder that I called Stata files, which is under the documents folder under the username my name. Okay, so let's start. I'm gonna run the first few lines. So here up to setting the directory. I'm just gonna make this smaller. Okay, so up to setting the directory, which is the first few lines. And then I'm going to create a log file. So you create a log file by saying log using, and then you choose your any name. Okay, I usually choose the name of the dataset. So college distance and then .log, and you have a replace command. So every time you're running this do file, you would replace the previous log file. Okay, so this one is just to open a file to insert all your commands and all your output in the log file. Next, you're getting the data, and the data here I have different options, whether a CSV, DTA, or even an Excel. So I'm just gonna have it as CSV. You have the choice to do whatever. I'm just writing for you the different options. What you have here is the data set already inserted in Stata. Okay, so let's start with the first one. The first command that I'm going to talk about is the t-test. Okay, so it's a one sample t-test. Suppose that I want to test whether a specific variable is equal to a pre-selected value. Okay, so whether the variable education is equal to 13.83 years on average. Okay, so a question that you might have is I'm choosing a specific variable and I'm giving you a pre-selected value and I'm asking you to check whether the mean of this specific variable is equal to this pre-selected value. So if we do that here, we get this output. So the output is telling us the education variable has 3,796 observation. The mean of the data is actually 13.82 or about 13.83 years, okay, with the standard deviation, standard error, and then standard deviation, and with a certain confidence interval. By default is the 95 confidence interval or the 5% significance level, okay. This is the part we need to focus on, like the lower part, okay, this part. So as you can see, the mean is already 13.83, and I'm asking you to check or perform a test whether the mean is actually 13.83. So your null hypothesis, this is the hypothesis that you test, okay, is that the mean of education is 13.83. And you have three different alternative hypotheses. A one-sided test, right? Another one-sided test, one on the left and one on the right. And then the middle one is the two-sided test. Okay? So every time these probabilities are the probabilities of the null or being equal to a certain value. So let's start with the two-sided test. My test here is saying education is equal to 13.83. The alternative is saying that the mean is not equal. So exclamation mark equal means like this is the symbol that we use for Stata for unequal to. Okay, so the mean of education is not equal to 13.83. How can I read the output of the test? Looking at the p-value, the p-value is saying the probability is 0.9809, or it's very high, right? When you multiply this times 100, it's 98.09% probability that the null holds true. In other words, there is a 98.09 probability that the mean of education is equal to 13.83. And again, when I say it's very high, I have to have a benchmark. So my benchmark is the significance level. So if my default is 5%, then definitely 98.09 is way higher than the 5%. So that's why I'm saying it's too high, okay? But I can also have a question about how about the 10% significance level? It's still high because 98.09 is greater than the 10%. 98.09 is greater than the 1%. So you can say under all significance levels, 1%, 5%, and 10%, right? We fail to reject the null. There is a very high probability that the null is true. So we say we fail to reject the null that the mean of education is equal to 13.83%. Okay? To be to check the one-sided test. The one-sided test is still confirming. So saying 49.04% that the null is true, 50.96% that the null is true. So we fail to reject the null under different tests, whether the two-sided test, one-sided or one-sided. In all cases, we reach the same conclusion of failing to reject the null that the mean of education is equal to 13.83. Okay, so under the three types of tests, we fail to reject. And also under all significance levels, because these numbers are way higher than the 0.05 for the 5%, the 0.1 for the 10%, or the 0.01 for the 1%. Okay, so whether you say you compare in terms of fractions or you multiply times 100, it's a probability by the end. So I'm writing for you here the answers based on the two-sided test, which is the one in the middle. And I'm making it sure that you understand that it has an alternative that the mean is not equal to 13.83, with the p-value is high 0.9809, which is greater than 0.05 significance level. Okay, so you can say it this way in terms of 0.05 significance level, or you can multiply it times 100 and say or 5%. Okay, so I'm just gonna write it this time, but I don't want you to get confused about when you talk about fractions or you talk about percentage. So it's up to you which way you want to go. Okay, so you can say 0.9808 is greater than 0.05, or you can say 98.08 is greater than the 5%. Hence, we fail to reject the null and conclude that the mean of education variable is not statistically different from 13.83. And then, since the probability is higher than also the 1% and the 10% significance levels, right? Because this number is still greater than 1% or 10%, then the conclusion is still the same, which is we fail to reject the null. The same conclusion. Again, using the one-sided test, the one on the left or the one on the right, we reach the same conclusion because the probabilities are again still higher than the 1% and the 10%. This part is very important and it's gonna definitely help you in answering the questions of your practice because I'm asking you these questions with a different set of variables. Okay, so I'm giving you a preset value of a certain variable. I'm asking you to analyze the result based on the 5%, and then I'm asking you whether the results change based on the 1 and the 10%, and then I'm asking you whether the results change whether I'm talking about a one-sided test versus the two-sided test. Okay, so so basically, if you understand this first command and all the analysis written in green in front of you, you should be able to answer the first 3 questions of this week's practice. Okay. Next, we have also something called a paired t-test. So as you can see, this is a one sample t-test. It's made on just one variable. How about I can do the t-test on 2 variables? So we call it a paired t-test. So what is the paired t-test? I have 2 variables. I'm taking the mean or the average of these 2 variables, and I want to see whether there is a difference in the values of these 2 variables. Okay, so we're testing the means of these 2 variables and whether the means are different from each other, or the difference in means is equal to 0. It's the same thing. Okay, so whether they are equal to each other, or whether the subtraction of mom call from that call is equal to 0. So we do that, t-test mom call equal that call. So this is how you perform the paired t-test. Again, the output is similar to the previous one in terms of the first part, observations, means, standard deviation, standard error, confidence interval, and so on. And this is the difference between, this is the difference between the means of the 2 variables. Okay, so this is telling us that this variable takes 1 when dad goes to college and or has college education, and this takes 1 when mom has a college education. And you want to see whether the mean of income, whether the mean of the 2 variables, not income, whether the mean of the 2 variables is different from 0. So what you do here is the mean of the difference, or the mean between the mom call minus dad call, is equal to 0. So again, the first thing is, this is our 2-sided test, the one-sided here and the one-sided here. Okay, so the left and the right part. And again, so is this difference is equal to 0? So you look at the p-value here. The p-value, there is a 0 probability that the null is true. Okay, in other words, there is a statistical significant difference between the 2 variables, or between the means of the 2 variables. So that means the 0% means that we reject the null hypothesis. There is a very small probability, and when I say small, it's smaller than the 1%, it's smaller than the 5% and the 10%. So there is a very low probability that the null is true. So we say we reject the null hypothesis and accept the alternative that the mean difference is not equal to 0. How about this one? Again, there is a 0 probability that the null is true, so we reject the null, that the difference is equal to 0, and we accept the alternative, right? They accept the alternative that the mean of the dad call variable is greater, right? Because this is less than or equal. So when you take this less than or equal here, so that means that call is greater. The mean of that call is greater than the mean of mom call variable. Okay? How about this one? There is like 100% probability that, so this test prefers that I go with this one saying that they are the same rather than saying that the mean of mom call is greater than that call. Okay? So again, when we go here to the answers I'm writing, the p-value is equal to 0, okay, which is smaller than the 5% significance level, or 0.05, okay? So okay? Thus, we reject the null and conclude that the mean difference between mom call and that call is different from 0, okay? So it's not equal to 0. So it is not equal to 0.